Alright, so welcome back to the DAT tutor. This isn't really DAT at all, it's just something that I'm learning in class, so I'm going to go over it so I understand it better. And hopefully, me understanding it, somebody that's really bad at calc, if I can understand it, you can understand it. So, first thing I want you guys to know is that when you see this sign, I wrote it up top, but if you see this, it is a clear indicator, as clear as it gets, that you're using this ratio test. Now, what is the ratio test? Well, that's a good question. It's to figure out if something is going to absolutely converge. So will it converge at a certain point, right? Or if it will diverge, which means that it's going to go to like infinity, or it won't actually converge at a point. So let's look at this problem, because I feel like me giving you this is just really confusing. I look at that, I don't know what's happening. Just know, anytime you see an n, see we have an n here. If you see an n for this first part, you're just gonna add a +1 on it. And I'll show you how to do that. Then you're just gonna divide by the original function, which is just the reciprocal of that. So just work it out, see if you guys understand it. So we know we're doing the ratio test because we see this little fun guy right here. It's a factorial. So immediately just write this out. The limit as n goes to infinity. First thing you write. And then just throw an absolute value sign right there. And we'll add the other one once we're done writing out the expression. So we see this n right here, right? There's an n here. But we know right here that there's supposed to be a +1 on that. So let's just go ahead and do that. So n plus 1, or this n, turns into an n plus 1, and it's raised to the 7th power. Perfect. Okay, we got that done. And now, you see we have the 9 here, so let's go ahead and write that. There's no n in there. But we see an n up here. Interesting. So we see an n, we know what to do, n plus 1. All right, perfect. So now we see a 2n here, right? So what we're going to do is 2, right? We're going to throw an n plus 1 where that n is. And then factorial. Let me move this down so I have a little bit more space to work with. So remember, we're dividing by the original series, right? And it's just a series, right? So we're going to divide by the original series. And how do you divide, right? If you have 7 divided by 9, or 7, let's just do this, 7 divided by 9 over 9 divided by 7, right? How do you divide this? Well, it's pretty simple, actually. All you got to do, write out the original, right? What's on top, not the original, what's on top. Then you're going to multiply it by the reciprocal of this. So what is the reciprocal of 9 divided by 7? Right, well, the 7's just going to go on top, and then you're just going to multiply it by 9, which is the reciprocal, right? Because 7 divided by 9 is the reciprocal of 9 over 7, which is what we see in the denominator here. So let's take that same logic and use it on this really weird looking problem. So just write the denominator on the top, 2n factorial. And I'm about to explain to you exactly what a factorial is, because if you're like me, you're not going to understand what the heck a factorial is. So let's just go ahead and simplify this, right? Just gonna move these. We're gonna, what do they call foil? You're gonna foil it. So it'd be 2n plus 2 factorial. And so when you see let me go ahead and highlight this so you guys can see what I'm doing, right? So you have this negative 9 n plus 1. Now there's some exponent rule out there. Just know that if you see two things being added in the exponent, right? Just gotta do 9 and negative 9. Then you write that n. Then you're gonna multiply by negative 9 to the first. So you're just taking this term, putting it here, multiplying, and then putting your 1 there. So let's go ahead and write out this new problem that we have that's a little bit easier to look at. So we have n plus 7 to the 7th power. Oh, what the heck? To the 1. And then we're going to have times negative 9 to the n times negative 9 to the first power, because that's what we determined here that we can do with our exponents. And it's going to be pretty important to remember when it comes to these types of problems, and a lot of problems in calculus. So just do that factorial, and we're just going to write out our original, right? But it's going to be the reciprocal, of course. You can go ahead and take out these bars, add a little multiplication sign to make it a little bit easier. So what is a factorial? What is this? What is this scary thing right here, right? Well, factorial, so let's say we have 2n plus 2, right? So let's say just minus 1, okay? Just think of it, when you see this factorial, just do, what's 2n plus 2 minus 1? Well, that's going to be 2n plus 1, right? And next, gosh, you're going to have 2n, right? And then what's crazy about that? So you see we did this factorial here, and we ended up with a 2n, right? And then this 2n, right? It does the same thing. It goes 2n minus 1, 2n minus 2, and this does the same, right? What's really cool about this is that, so this doesn't cancel out with anything here. This doesn't cancel out with anything here. But if you see this, our 2n's cancel out. And then, oh, our 2n minus 1 also cancels out. And this keeps going, and this also keeps going, but they keep getting canceled out, right? So what does that leave us? If we're canceling out these terms from here all the way down, we're kind of just left with this, right? So let's go ahead and write that. So since we know that this 2n factorial will cancel out, this is going to cancel out as well. We also have that 2n plus 1. So let's go ahead and rewrite this. So the limit as n approaches infinity. Make sure you always write this down. Don't forget it. I do it all the time. Don't do the same thing I do. 2 to the 7th times negative 9n times negative 9, because this is just the first power, so negative 9 to the first power is still going to be negative 9. We're going to have our 2n plus 2, 2n plus 1, and then our 2n. Ooh, allergy season is crazy. And then we're going to have our 2n here, right? This is all factorialed, I guess, but we know what we're going to do with that. Right, this is just going to cancel out because of this idea right here. And this is also going to cancel out. But if you notice, there's lots of other things, or at least one thing you can cancel out. You could have this negative 9 here that you can cancel out. Nothing else you can really cancel out here, right? So just leave it at that. If they look the same, cancel them out, right? So we also see one thing you need to take note of, right? Say we have these absolute value bars here, right? What does that do? Well, that just makes everything in here positive, right? So this negative 9, let's go ahead and make it a positive 9. And I don't see any other negatives in here. So let's just go ahead. We took our absolute value, right? So screw that. We're just going to write our parentheses. I'm going to do 7, n, n plus 1 to the 7th times 9 over our 2n plus 1, 2n plus 2, and then 2n plus 1, then our n to the 7th. All right, perfect. So now you're probably asking, well, what do we do here? What I like to do, let's go ahead and highlight our coefficients, right? That's going to be a 7. This is a 7. If you just see an n here, just remember it's going to be to that first power, right? Because anything to the first power is just itself. So just remember, this is a 1 and this is a 1. And you can probably do this math in your head, but I'll just write it out. So write out your coefficients off to the side. So you have 7 on the top, and you have a 1 plus 1 plus 7 coefficient. So what is that, 7 over 9? So that means that, what that means is that the top, right, this top part is going to, let's say it's just a number, right? And then the bottom's bigger because we're going to infinity. So if our bottom coefficient's bigger, we're going to have a 1, right? This 1, any number over infinity equals 0. Remember that, okay? So if you see that this denominator is bigger than the numerator when it comes to coefficients, just think, oh, we're going to 0. If this limit is going to infinity, that means we're just going to have a number over infinity. And that's just 0 every time. So all you got to do is say, this goes to 0. This goes straight to 0. And then something you need to know about the ratio test, we'll go over other practice problems to give you different examples. But if you have a 0, that's less than 1. And that's important to remember for the ratio test. Because if anything is less than 1, if some number that you get from this is less than 1, you're going to absolutely converge. And that's all you really need that's your answer, right? You're going to have this value of 0. You're going to know that it's less than 1. I didn't even write it. Less than 1, right? So therefore, it will absolutely converge. Really quick before we start this problem, I know these questions are a little bit on the harder side, right? But I don't really want to give you all these easy problems that you're never going to see on your test or any assignment you do. And I feel like that's something that I've ran into. It's just they give me all these really easy problems like on the test or any assignment, and I'm like, I've never seen this before. So that's why I'm giving you a little bit harder questions, but yeah, I'm done with my rant. Let's go ahead and work this problem out. So we see these ends, right? What is our rule with the ratio test when we are gonna do the ratio test? It's our ends turn into n plus 1. I'll put those parentheses around it because I like to do that. So we're doing the ratio test. So we write our limit as n approaches infinity, absolute value bar, right? That's only going to change your negatives to a positive whenever we're going to plug in our infinity. So keep that in mind. Just write your absolute value bars. Sometimes you won't use them, sometimes you will. Just your teacher will count off if you don't. So make sure you do that. So you're going to have 2n plus 1 over 4n plus 1. And that's all going to be squared. Or not the 4. I'm being dumb. Just as n plus 1. Because if you look over here, your n's getting squared. So just don't listen to what I just said. Just do that. Okay? So then you're going to have your 4n plus 3. That's your reciprocal. Remember, flip these when you are going to do this problem. And that's going to be your 2n. And beautiful, okay? So what we're going to do next is we're going to FOIL this, right? Then we also see, oh, we have a little exponent here. What does this do? That's just your 2n plus 1. And then we had our exponent rule, right? Remember that? So that's just going to be 2n times 2 to the first. Anything to the first is just itself, so this is just 2. So let's go ahead and rewrite this. The limit as n approaches infinity, absolute value, for some reason, 2n times 2 over 4n plus 4, right, because we FOILed this, 4 times n, 4n, 4 times 1 is just 4, and that's all going to be squared. Then you just got to add your 3. Then just write out your other parts. Number reciprocal, and then close at absolute value. So now that everything's simplified, let's go ahead and cross some things out. So we see our 2n here, and yeah, that's it. And one of the biggest things I want you guys to realize is your n exponent probably needs to cancel out. Right? But there are some instances where they don't, but I will get into that probably in a different video because that's a little bit tricky. So, is everything positive here? Yep, it looks like everything is basically positive, right? So, we can go ahead and get rid of these absolute value bars. Let's just rewrite this. The limit as n approaches infinity, parentheses, screw those absolute value bars, be 2 times 4n plus 3 over, we're going to have our 4n plus 4 squared plus 3. All right, perfect. So, did I do something wrong? I did do something wrong. This is squared. Oops. So, my bad on that. So, we're just gonna do a little bit of that. And so, let's go ahead and distribute this out, right? So, let's have your 2 is gonna go here, and your exponent of 2 is gonna go there. So, what's 4n squared? 4n squared is 4n squared. And then you're going to have plus 16 plus 3. So we're looking at this and we're saying, okay, our 4n's do cancel out. So if it's a plus, this whole thing's going to cancel out, right? And this is all plus 2. It's 4n plus 19, or 16 plus 3. So this whole thing's going to cancel out. What does that leave you with? Well, it just leaves you with 2 over 1, right? And that just equals 2. Okay. So is 2 greater or less than 1? Well, 2 is actually greater than 1. So if this is greater, when you get your sum number, if it's greater than 1, it's going to diverge. Any number that is greater than 1 will lead to a diverge. All right, hopefully this wasn't too confusing when I messed this up, but I can always redo that. Just tell me if I need to redo that. The problems keep getting longer, but trust me, it's the same every time. So, we see our n, what do? Turn that into n plus 1. So, doing the limit, we're doing the ratio test, so limit as n approaches infinity, absolute value, make it robotic. It is essential that you write that down. So 5, and then we're going to turn this n to an n plus 1 plus 2 over, and then we're going to do the same thing here. That n is going to turn to an n plus 1 plus 1 to the 6th power, and then extend this out a little bit. We're going to have 7 n plus 1 minus 2, and then reciprocal of the original function because we're dividing by it. So it's going to be n plus 1 to the 6th, and then 7n minus 2 over 5n plus 2. Let me break this up because there's a lot of parts to simplify here, right? So we're going to have that. We are going to have this to simplify. And we're going to have to simplify this. And while we're at it, let's simplify this. Both of these. These are just exponent rules, but let's just go ahead and do it. So let me go ahead and write down this exponent, right? N plus 1 plus 2. What's 1 plus 2, guys? Come on. Surely we know that. N plus 3. If you got something different, you might be cooked. But all this is 5n plus 3, because this was our exponent. And then we can use our exponent rules. Just be like, oh, same base with exponent. It's just 5n times 5 to the 3rd. That is a big number. Okay. So that's our simplified version of this. So we're done. Let's go ahead and simplify this now. So n plus 1 plus 1. 1 plus 1 is 2. I know it's challenging, but I believe you. I believe in you guys. And that's all inside of this parentheses to the 6th power. Let's go ahead and keep that going and have n plus 2 to the 6th. And that's our simplified form for that. So let's go ahead and simplify this. So n plus 1 minus 2. Oh my gosh, there is a negative. What do we do? Same thing. What is 1 minus 2? I hope you got this. It's not a trick question. It's n minus 1. Then we'll use our exponent rules to say this is 7n times 7 to the negative 1. Beautiful. So that's our simplified version of that. And we're just going to use our straight exponent rules on this. Right? This is just 7n times 7 minus 2. It's just 5n times 5 to the 2nd power. Perfect. Okay, so everything's simplified. There's a whole bunch of stuff going on. Let's just go ahead and write this down to where we can actually look at it and not want to cry. So we're going to have 5 to the n times 5 to the 3rd all over n plus 2 to the 6th. And then we also, I put this in the wrong color, but this is just 7n times 7n times 7 minus 1. Then we're going to write out our simplified version of our reciprocal of the original function. So that's n plus 1 to the 6th. And then we simplified out our 7 by using the exponent rule. And then this is going to be 5n plus 5n times 5 to the 2nd. And we simplify that out as well. So let's go ahead and just cancel some things out. So when you see these negative signs, how do we make them positive? We hate negatives. I don't like them. You don't like them. How do we fix this? Well, if we move our negative 2 to the bottom, this turns into 1 over 7 to the 2nd power. And same thing for this. If we move this to the top, it makes it positive. So that's 7 to the 1st. Let's go ahead and write this down. This is a rule you need to know. You just want to move your negatives and make them positives by moving them across that division sign. So this didn't cancel out, but we just moved it to the top. So let me just go ahead and write this down like this. We just moved them. So what actually does cancel out here? We have this 5n that does cancel out. We have a 7n that cancels out. And oh, I guess we can do this as well. We can say that this 2 has the same base. This cancels out. That leaves us with the 5 to the first power. And we also see that here, right? This 7 to the first cancels out. And that just turns this into 7 to the first power. So let's go ahead and write this out in a way that we can see it and not cry again. So there's no negatives. I don't see any negatives here. Don't see any negatives here. So let's go ahead and get rid of that wonky absolute value sign. So we have 5 times n plus 1 to the 6th, and everything else canceled out, over n plus 2 to the 6th times what we have left. This canceled out. We have our 7. Perfect. Let's go ahead and put this to infinity, right? So what's our coefficients? We have a 6 here and a 6 here. There's no other coefficients, so that's just 6 over 6. So what does that mean? Both of these cancel out. What does that leave us with? Well, that just leaves us with 5 over 7. And is 5 over 7 greater than or less than 1? Well, 7 over 7 is 1. 9 over 7 would be greater than 1. So 5 over 7 is less than 1. So what does that mean? If a term, when you're doing the ratio test, if you get some number that is less than 1, it absolutely converges, right? So absolute converge. And that's how you would answer that problem. And that's going to be my basic intro to the ratio test.